Hundreds of thousands of researchers around the world are working to improve life and address imminent threats to humanity. Often their research ends up in the scientific valley of death in the form of publications and patents that never see the light of day. That is about to change. Welcome to the Lab to Startup podcast, hosted by Naresh Sunkara, founder and executive director of the Berkeley Postdoc Entrepreneurship Program at the University of California, Berkeley. This show has two main goals: share the stories of those who have successfully founded startups based on their own research, and highlight resources needed to help those aspiring to launch startups in the deep tech space. Whether it's electric cars, vaccines, addressing climate change concerns, or possibly establishing life on other planets, Naresh and his esteemed guests want to help scientists, engineers, faculty, and researchers bring their innovations to market. Learn more and subscribe today at labtostartup.com. And now, here's Naresh.
My guests today are Donna and Mike Rainone, the founders of PCDworks. PCDworks is a technology development company that helped develop hardware for over 50 big companies in the oil and gas, transportation, healthcare, and several other industries, and now helping startups with a new incubator model. In this episode of Lab to Startup, we first talk about lessons learned from building innovative hardware products for big companies, how they use principles of epistemology while developing new products, how they borrow lessons from their training in psychology, architecture, and engineering in this process, challenges with innovation at big companies, and then talk about their transition to helping startups with all this experience, where we talk about their ideation sessions, how they work with founders, their observations on common mistakes that founders make in the hardware space, infrastructure they provide, and related topics. I was introduced to Donna and Mike by a mutual friend, Brian Bartholomew, at Stanford University. I've seen a number of incubators and accelerators around the country, but super impressed with what Donna and Mike are beginning to do in this hardware space. We need more such people and institutions to support hardware startups. Hope you find this conversation very useful. Donna and Mike, nice to have you both on the show today, and thank you for taking the time. Let's begin by getting a 30,000 feet description of what PCDworks is all about.
PCDworks has been an evolution. Our mission has evolved into supporting people or companies who have big ideas and don't know how to execute on them, or don't have the bandwidth, don't have the freedom to think about it in a continuous and focused manner. So we help them with that. We do a lot of heavy science on it. Mike can talk about our process, which is really kind of evolved too. We have a pretty set process we do, which is based on scientific method: test, develop, prototype, test over and over, over and over. And that's what we're here to do. And the Basecamp has evolved from that for startups, entrepreneurs, smaller entities, because of Stefan and Kemp from Rainone. They were our first Basecampers, and it was a great experience for us and them too, I believe. And we thought we had another mission we could fulfill, which would be to help entrepreneurs, not just big companies.
Mike, I saw this Basecamp thing on your website. Maybe we can start there. What is all this Basecamp about? Tell us the story behind the name. Why do you end up there?
Let me start first, because he doesn't always remember this. We have a campus here in East Texas, and we have 7 buildings, 7,000 square feet. We've always had trouble with the name of it. I thought, what does it do? And it's the starting point for a long climb. And that's where I came up with the name Basecamp. And then the idea for what we did there evolved from there. So that's really where the name came from.
And the hard tech part of that partly came from Stefan and Kemp at Rainone, because they clearly said, we're out here in Silicon Valley and everybody wants to do software. We don't have anybody that knows how to make things out of heavy equipment and steel and drill and motors and controls and stuff like that. So the notion of a Hardtech Basecamp, which it literally evolved from PCDworks, because we have always been a place where big corporations have come to us with a team, with a market notion of what they want to build, and a mission to figure out how to do something with technology, not software, but maybe mechatronics. But when you think about what big corporations are good at least the ones we deal with, They're good at making things once they know what they're going to make. They have manufacturing, they have sourcing, they have purchasing, they know who they're going to sell to, they have done financial analysis, they allegedly know what the market is, but sometimes they don't. But at least they're that part. What they don't know how to do is make the technology work. That's it. That's where the PCD part of this came from. We started with an interest in simply taking technology that's available and applying it. What that evolved to is they would call us and say, we don't know how to do this, or we don't have the time to do this. We don't have the people to do this. But mostly they didn't have the freedom nor the focus to do it. Most corporate engineers are very competent and capable. But between one kind of training and this kind of training and being stuck in an office building with windows out and boards all over the place, they are distracted constantly. And this place is a place for focused ideation, focused invention, focused testing, focused hypothesis building, and focused knowledge gaining.
And the campus is key to that because we're out in rural East Texas, we're remote, and the idea is to get them away from their normal environment, collaborate and produce ideas, and then turn those ideas into tests and prototypes, and hopefully hand over something that they can make into a product. The campus is important.
I think there's so many threats we have to go after that you mentioned in this, but it looks like a lot of your earlier work was working with big enterprises. Give us a history of where PCDworks started, and then I think it evolved into startups. So talk us through that journey of what are problems that you're trying to address for these companies. Clay Christensen in his book, Innovator's Dilemma, talks about how big companies are incapable of innovation because they have quarterly goals and money they have to chase. I'm guessing your story is along those lines, but if you have any specific examples of like some of the work that you did with big companies, the problems that you're trying to solve and how you changed their path, if we may call that.
There's so many. There's so many stories. Mick, do you want to start with the Navy project?
Let's start with one of the oil patch guys, oil service companies. They were in competition with another company to develop a downhole safety valve, subsea safety valve. And the other company had come up with a technology to do this. And they called us and said, we think there's 3 ways to do this. One was rotary motors to drive the safety valve down. Another was shape memory alloys to pull it down. A third one was linear motors. And they said, could these work or something else work? We don't know. So we had one of our immersion sessions where we got them up here for 3.5 days, and we stimulated their thinking and helped to resolve the possible ways to do this. So we fleshed them out, and we did what we normally do, which is to go to first principles and start looking at the kinds of forces and the requirements and the heat to see which one might be feasible. And so we ran the gauntlet through all of the different alternatives that came from the immersion session and met with them in Houston. And I'm going to say a bad word, but this is exactly what they said. I laid it out. We said, okay, you can do this or this or this. And the big boss looked at me and said, God damn it, Mike, I didn't ask you for choices. I asked you to tell us what to do. And I said, okay, we're going to do a linear motor. That was it. And so we searched around all over the country looking for motor people that could help us. And it turns out that linear motors are not done in this country. So we literally packed up and moved to Romania for a period of time after we had studied. And one of the great lessons that I have learned about what needs to be done is that when you go hire an expert, you had better study his stuff so that he doesn't think you're a fool and he doesn't spend the time teaching you, but really you have to be focused on what he has left out of his writing. And it turns out when we were looking at that motor, he looked at it and said, well, you got it already. because we had designed it and laid it out, had all the stuff in. And he said, "Oh, what did you think about the back iron thickness?" We spent a week making it feasible by making sure that we had the back iron right. And that's what it took to do it. That was one of my favorite experiences of all time. And we literally built the thing, built the motor, big linear motor, and it literally morphed into a pump eventually that lifted 8,500 pounds of oil, 13,000 feet up on 90 kilowatts of power. We were wiring it to deal with 1,200 volts at about 65 or 70 amps. And we developed that on our own, built it here, prototyped it, tested it, and shipped it off up to them for full development.
That is a super impressive story there. How did you end up in Romania?
I called the number one motor school in the country and I said, "We need a motor expert." And they said, "We've got them." And then I said, "A linear motor." And they said, "We don't got them. We don't do them here. You have to call this person or that person," one Englishman and one Romanian. And the Romanian turned out to be much easier to deal with and welcomed us over there. He'd been teaching 5 or so years in the United States, but the immigration stuff had gotten to him. He said, "I can't get in the country. It'll take forever to get in. Why don't you just come here?" So we flew to Romania.
The bottom line on this is that Mike's not afraid to pick up the phone. He's persistent. He will find somebody eventually who can help in anything.
I am not, but I play it because I am a trained psychologist, an experimental psychologist, not a clinical psychologist. But I'm just a dumb old psychologist, but I've got this technical issue I have to deal with. And people just open up because I'm not a threat. And I befriend them. And by the way, I also study before I start talking to them so that I don't appear to be a fool. I've got dozens of folks that I can call on from everything from antenna theory to fluidics that will help us and that we can use for the esoteric parts of development.
You bring up something very important about psychology. Maybe that's a nice place to plug in about your educational backgrounds, because Mike was chatting with you earlier and you talked about how psychology plays a role in everything from product design to just communicating with these people and not feeling a threat. I'd like to connect those dots between you two. You both met at the University of Texas, Austin.
We met because I didn't want to be a psychologist. I went to architecture school and I taught in architecture. I taught person-environment relations, how the physical environment affects behavior. That's where I met Donna, and I have a master's degree in architecture.
I will say, though, maybe this is a good time to say that we complement each other in our skills. I very much revere him for his psychology. He knows how to design an experiment. He has statistics background. He does a lot of the engineering. He's more the engineer type. I'm the designer. And I was, in my architecture career, a project manager. So I use those skills and he uses his. So we complement each other. And that's probably why we don't argue about business a whole lot.
And I think Donna is hitting around a point. Product architecture is design. In fact, the industrial designers sometimes talk about product architecture because architecture is an integration and a process of making things better, but integrating and making the product work. And she brings that integrative thought to our effort to integrate stuff. Now, the psychology part of that, the most important thing that I learned is a doctoral level, not undergraduate, not master's, but doctoral level psychologist, was the notion of how we know things, the epistemology of things. Where does the knowledge come from? And the truth is, every decision that you make about everything is a hypothesis, whether it's how am I going to get to work, how long it's going to take to get to work, what turns, those are hypotheses. You've done them over and over again, and those things pretty much, you don't have to think much about those decisions. But when it comes to something like, how do we know this is going to work? Or is this the right thing to do? Or is this step, this is a hypothesis. And every aspect of the product development process is a hypothesis. Is there a market? Can I distribute it? Am I going to get in trouble with the intellectual property? Will the technology work? Is the market important? Do I have enough money? Can I get it manufactured? Each step of the feasibility to decide where to go every step of the way is a hypothesis that must be tested over and over again. Do you have the right market research? Do you know who's going to use it? Do you know how much they're going to pay for it? Do you know how much I can spend to develop it? How much are my NRE compared to production costs? How many am I going to sell? How does that fit in with the full development? Can I make money with it? Who's going to sell it? How do you build a sales team? And most important of all that is the person I'm working with going to complement and be honest and dig in as much as I am going to dig in. Do they bring complementary skills? Because one of the things that we think is most important is that team, whether it's 2 people or 10 people. How do you get along? Are they going to get along and get through this thing? I think that's what people are betting on, really, at the end. Is this group of people credible to get it done? And that's a hypothesis that investors are making. They are making a bet. And to the extent they gather the data, they look at your resumes, they look at the experiences and stuff, does that increase the probability of success? Because that's what product development is. It's hypothesis testing, risk reduction at every step of the way for every aspect of the feasibilities. That's what I learned as a psychologist.
You bring up some very fundamental points, and I think the hypothesis-driven thinking about every aspect of building a business, whether it is product or on the business side, is super important. You mentioned something about, I think it was Donna who mentioned about immersive ideation sessions that you guys do. Maybe you can walk us through what that sessions look like. Maybe frame it in such a way that, like, when a big company comes to you, what are the general things they lack in, and what happens after this process of immersive ideation?
Well, let me start, and then you can take over. I'll start with the soft part, because there is a soft part to this. We just bring them here to our campus. We usually bring them in the evening. First day is an evening meal together. We break down barriers. We have beer and wine, and we try to relax them and get the my dog is bigger than your dog out of the room, and have them start to work together as a team and to loosen up. Really, that's the point of that. It's like a big family meal, and we have fun and we talk, and there's before meal stuff and after meal. And then the next day we launch into a pretty rigorous ideation session, or immersion session as we call it, because we have to learn from them as much as they will learn from us.
It even starts earlier than that. When we're engaged, it usually takes about a month to go visit with them, get problem clarity, start to get specifications, understand really what the problem is, make sure they've got the problem right, because you'd be amazed the number of times that's like, well, this is what we want to do. And it's like, wait a minute, are you sure you've got the right problem here? Big corporations are pretty good at that, because the marketing people and the product folks usually know what needs to come. They need to solve. That's something.
But it has happened where you end up saying, oh, we're addressing the wrong problem. If you dig deep enough, sometimes you find that, because different people involved have different perspectives.
So we spend a month, not down there, but go interview, we talk to them, get ready, and then we look for stimulus material. We look at all the parallel kinds of things that could be similar. For instance, if we're doing a pump, we look at how giraffes' hearts work to pump, how the human heart pumps. In fact, the oil patch folks have figured this out. They used to have a pumps and pipes conference in Houston, where the doctors, the medical folks, and the engineers on the oil patch would get together and talk about the similarities between pressures and valves and things like that in the body. And one of the earliest projects I ever worked on was a left ventricular assist device that was actually developed by NASA engineers for one of their fellows who was having heart problems. And they took a turbo pump from the Saturn and sized it down to about 1.5 inches in diameter. And that thing would pump 10 liters of blood per minute like a maniac. It was amazing. There is all of these parallels. So we start looking at all of the peripheral stuff that are not necessarily associated, but might relate, might stimulate someone to go out of the bounds of their normal, this is the way we do it all the time thinking. We have big posters and we put them up in our session room. I have a poster of Rodin's Thinker, and the phrase is, you can't grunt your way to creativity, because of what he looks like he's doing. He's grunting there. So the first night is to get over the ego thing. And why is that? Because as a psychologist, I understand that there are layers of non-conscious barriers in your mind that when you are uncomfortable, oddball thoughts won't even come into the conscious arena to spit out, because those levels are non-conscious. They're pushed down by the environment that you're in. If you're with the boss, you ain't going to make a fool of yourself by saying something wildly creative. You're just not going to do it. And it's not that even your mouth won't open to utter it. You won't even think of those things. It's a barrier below awareness. And so when you create a comfortable, non-threatening, we're all here together, hail fellow, well met kind of environment, then those thoughts, the craziest things can come out and nobody's going to make fun of you. They're just going to go, that's weird. I don't know if that'll work, but this might work. And they modify it and they fix it. So we always start with decomposition. Decompose the problem because you've made assumptions about that. Let's get the assumptions out of the way. And then we start with the normal immersion process of, I wish we could do this. Or how do we do that? Or why can't we do this? Don't reduce it to a gadget, but just a wish or a how-to or what if, things like that. And then we generate 300-400 of these fragments. And then we give people a sheet and say, circle the ones that you like, 2 or 3 of them, and go embellish it, develop it a little bit, take it a little further. And so the whole idea is to get them to come up with the wildest I wishes and then reduce that to maybe it looks like this. I don't know. We've had a session where we built pond boats and floated across our pond just to exercise the craziness. And we had guys get in the pond with a sinking styrofoam or egg carton boat. This is kind of the exercise you do to make it fun, because fun is fundamental to being creative. No question about it. The hard part of the session is the evaluation. Okay, now we got 100 ideas. How do we distill those down into the 3 things that we can go and test and start our testing process? We have evolved techniques to distill that and take that funnel and take it down to just a few things that we are then handed. And they say, these are hypotheses. Go test them. And so that's where the next step is for us to do the mathematical modeling, the CFDs, or whatever it takes to start distill down and look for, first of all, what the hard part is to solve, and whether or not we're trying to violate some law of anti-gravity or something like that. That's what is yielded out of that session and the next phase.
Donna and Mike, I think you brought up the soft aspect of what you do in the initial phase of ideation. I think it's super important. Mike, you talked about letting loose your craziness, because we as humans were taught to not speak what you think. We put up barriers, not think freely, with the fear that somebody might call us out on a stupidity. If you have to be very creative, I think that has to be lowered and all barriers have to be broken. and put up all the possibilities on the table. And I love what you're doing in terms of just taking how a heart pumps. And I didn't know about this oil and pipeline conference that you talked about, where physicians and like engineers are coming and talking about how you pump things and then you bring that biology. That is peripheral thinking. I don't know if that is a term, but we got to expand our knowledge by talking to other people. I love what you guys are doing there. I think that's a nice segue to talk about. That is a big company point of view. But it looks like you have transformed into working with startups now. I usually start my conversation by framing the problems you're trying to solve. And as I was doing my research, I found an interesting quote by one of your board advisors, Michael Martin, who said, bottom line is that you haven't met another PCDworks. Every engineering firm on the planet will claim to be able to solve the toughest problems. I don't know of hardly any firms with capabilities, depth, and flexibility that PCDworks has. They're like the Green Beret of engineering and technological information. That's a big compliment. Maybe here is a good point to talk about the problems that you guys are working on when addressing startups. Maybe a list of problems that you thought other facilities are doing it not the right way, or you're doing it better. And then we'll go into some examples.
I would say the reason we're doing small startups is we've been in business since 1997, and we've seen so many, and like you, we've made mistakes. We've learned a lot of lessons. We've honed our process, and we thought, well, we could use that to help a startup avoid some of those pitfalls. And what Mike has done in an informal way, there's no document out there, but he did this with Rainone, and he's doing it also with the next candidate for Basecamp, is he guides them to prepare them to come here and have us support them. And he does that by, he knows all the components you need to have to not ensure success, but to lay groundwork for success, like make sure you have your marketing. If you need an expert, he helps find them. He guides them with, are you sure that you're doing this part of it correct? And he doesn't say you're incorrect. He just wants them to rethink something. He's the guide on this climb up the mountain. If you want to use the mountain climbing base camp metaphor, he is the guide. He's the person showing them the way, the best way. And not that he always knows, but he can stimulate them to think about things that they need to consider, from money to technology to timelines, etc.
After this many years, and I've actually been in product development since about 1986. It's quite a few years. And I have done many, many wrong things or missed things. And so I know the things that I've watched other people miss and that I've missed. For instance, you asked partly why we're doing it, because it's a legacy and we want to give that back. We want to help. We've been blessed by having lots of big projects, and we're evolving even more to do more fundamental stuff right now, inventing technologies that just don't exist. And that's really fun.
Yeah, it's scary too.
But it's a wonderful challenge. It's great fun. And knowing what we know how to minimize the risk and what knowledge to gain on a step-by-step basis to continue that. Now, we want to help the startups because, frankly, Rainone came. I had known one of them, Stefan, for years because we worked on a food equipment project. And when he got through the program at Stanford, they started calling me, and I would do things like, have you talked to the regulators yet? Oh, yeah, we need to do that. Where's your IP? We're kind of working on it. Okay, you need to do that. Have you got the financial technique? Yes, they have that because the Stanford program really does teach them to do a thorough job. They were having to make, over the course of the semester, the quarter, 50 phone calls to ask questions about this and that and this fact and that fact. And all I did was sort of nudge them in directions that they should go. At the end of that period, they had a pretty good financial model that made sense. Our partner, Bert Sackett, worked in the energy generation business for years, led a big group of software programmers at Boeing, and worked on Con Ed software in New York City. And he looked at that and said, this is a good idea. So I kept nudging them along. And finally I said, well, we have a 3-story building. We're going to drop a weight down in Palawan. And I said, you what? What do you plan on gaining from that? Well, maybe we can generate some electricity. And I finally said, come on down. I talked to everybody. We just invited them to come down and stay with us for a couple of weeks. And we took an old riding lawnmower frame, put a motor on it and a winch, and we happened to have a water well that we had not plugged but was there. And we hooked the thing up and dropped the weight down, and lo and behold, it generated electricity. Just, we couldn't quantify it.
So our first step on that was junkyard war stuff.
At that point, they started raising real money. And it was like, okay, we have some more money. We want to grow this. And we ended up, while they raised money and bought big chunks of equipment, we did the electronics and the controls and the frame and all that and had it built for them. But they oversaw everything, and they lived with us for 22 months. And they were the best fun that you could imagine. I'm not sure we'd do that again, but the time passed and they were so incredibly delightful that it was like having our own kids here. And that kind of experience may ruin you, because we are going to have more base campers and have a place for them to stay. They don't have to stay 22 months. They can stay a week at a time. As long as they come back in to focus on what they're trying to do, they can run back and we'll work on the stuff for them or whatever. We'll help coordinate. But we want them to know they have a place to stay and they don't have to rush in and rush back out. They can focus. And that is the key, to be able to devote time to focus on this, because it's the one thing you know about startups. There ain't no shortcuts to success. You're going to have to work your butt off to do this. And the more you could do it unencumbered by having to run back here or run back there, the better off. You know you've got a place to stay. You know you're going to get fed.
The other thing is that a startup is kind of a lonely experience. I think you probably said, Naresh, that you've done that. And to have a team behind you here is comforting. And little things come up that you never encountered. And then you've got other people to help solve problems. It's like having a mini company before you have a mini company.
And the thing that is hard to really picture is the spontaneous, unplanned discussions that come from being together. And it's like, over the dinner table, you talk about, hey, what if we do this? What if we do that? What if we change that? Those sorts of things that are just spontaneous and not planned builds the richness of the solution and helps you build the hypothesis to go and test and gather more knowledge.
This is so refreshing. I've seen all kinds of incubation and accelerator models around the country, around the world, actually. It's almost like a predefined program, and a lot of places focus on pitch deck, I think, and introductions to investors or some advisors. That's what a lot of them focus on. But then I think building hardware is really hard. I think I'm stating something that is very obvious, maybe not to too many people. But what is happening on your campus with Renewal, for example, they came in for about 2 weeks, ended up staying for 22 months. Their ideas were crude, if we might call it, but then you help them refine and then help prepare them for getting funded, whether it is funding agencies or private investors. I think that kind of focus is super important. Having people with systems thinking, I think that's what you bring to the table. It's biology, it's not psychology, it's engineering, it's everything. And that constant back and forth is going to be super important. I don't know if some team wants to approach you to work with you guys. What would that process look like? How do you select startups to work with you?
We're still evolving this. We're still trying to define how this all happens. We know that while we can advise and kind of nudge people in the marketing and the financial analysis, what we're really good at is taking the concept for the solution and making it real and testing it. That's what we're good at. We know that we like them because knowing the market is so hard. We like it when they come in with a good market plan, and somebody has seen that market plan and feels comfortable enough about it to put some money in it. That gives us poor dumb engineering. There's somebody that thinks it's real. I think it's real too, but it's nice to have that confirmation.
It's not technology in search of a market. They have to know what need they're fulfilling first. And not that we're marketers, but we know that they need that. That's one of the things Mike guides them to do. Go do your market research, and he makes suggestions. But really, we kind of have to prepare them ahead of being here, making sure they have everything. And Mike is just really good at finding a germ of an idea that he thinks if they just do a little more homework, we can help them get them launched. And again, because we've seen this all before so many times, he knows the key things they will need, and he will guide them. And that's when they come in. And it's the market research. It's the have a little bit of money, somebody who believes in you, have a financial model of some sort. It may not be correct at first, but at least you've tested something, and then go from there. We have an informal checklist, and then we do the guiding.
The other part of that is it's become increasingly apparent to me that knowing how you're going to sell it is really important. How is it going to get in the market? And if you say to me, well, we're going to go out and license it to somebody, show me somebody that has more than a passing interest in this, and then we'll talk. And a letter of intent is worth the toilet paper it was written on. I want to see somebody who's serious about this. I'm not sure what it is, but I'll know when I see it. If I see 4 or 5 letters of intent, that's one thing. But show me that you've done that and you have a way of distributing and that people are interested in that. And show me that you dug through the patents. Not that you have to have it done, but you probably need to have a provisional filed on something. That is important. And provisionals are so easy to file. You need to have done that on a solution of some sort. And the market research, we want to see that before, and we'll help guide, but before we say, come to us and stay here with us, we'll work through the details. The other part that lets me do is when they come in with an idea on how to do it, I am pretty good at sniffing out anti-gravity. I'll look at going, you got this and you think this, but there's a piece in the middle here that I don't know if that exists. And I don't know if you can really do that. So that's the thing you need to focus on, and we need to focus on to test the hypothesis that you can do that hard part. Because if you can't do the hard part, then doing all the dumb easy part is stupid, because you just got somebody's money away, and that's just dumb. Solve the hard part first. This is the problem, by the way, with university folks. And I think one of your other podcasts I listened to, it's like, don't develop products because you can do the technology. Do the products because they solve a problem. And I have taught industrial design students how to go seek problems. That's the most important. Look for problems, seek it, and know that you're going after something that is really a problem.
This is, like you mentioned, a lot of scientists do this. There's a technology in search of a market. That's a hard problem to solve. Work the other way. And you mentioned some other important point about work on the hard problems first. I just finished reading the book Quit by Annie Duke, where she's talking about people build pedestals for monkeys, where the monkeys are going to be dancing on the pedestal. But instead of teaching the monkey how to dance, they're building the pedestal because it's an easier problem to solve. And there's so many pedestals and no monkeys to dance. I think this is a very common problem. I'm glad you're addressing that. So that's good information for people who are trying to consider coming to you. Maybe this is a good point to talk about the facilities. What are the technologies that you have to offer to people who come to you to build hardware?
By the way, the problem with the universities is that the incentive structure is different. Commercial companies, people who do products, want to make money. Professors are typically rewarded for publications. Whether that applies to something, maybe at the end it will, but maybe it doesn't, or it's a long stretch to do that. But I think there are universities Well, I know of one that rewards faculty for businesses and products launched, and that's Texas A&M. Towards tenure, if you launched a product, that adds to your tenure.
Wow, I didn't know that.
Well, I don't know if it still is. Gosh, they change all the time. But that is really smart to do that.
I will read up on that. That is such a great model. People just should not publish work and move on, I think. And this is taxpayer money that we pay. And I think there should be an intentional effort to translate that something that people are going to use it. And it falls on the scientists or the engineers. Nobody's going to come and pick up your technology and do something. That is part of the reason I do this podcast, to encourage them to just don't publish and perish. You need to do something about it. Going back to the equipment and all the facilities that you have at your site.
We have a prototype shop with two CNC machines, and we have lots of 3D printers, and we also have a pick and place machine.
We populate our own boards,
which was a necessity because of the supply chain issue after COVID. So we bought our own machine. We make our own boards.
It was a sort of a survival of the fittest question, because during this shortage of electronic parts, if you design something and send it off to the board maker, they'll right back say, we can't get these parts. But if you go find the parts first and kind of know where you're going, you go buy the dang parts, you design for it, you run 10 to 50 prototypes on our pick and place machine. We test, again, hypothesis test, and then we say, okay, it works. And then you can send it off to the big guys to have thousands of them run. And by the way, we might buy 1,000 parts, only use 50, and then we send off the remainder off to the big contract manufacturer and say, here are the parts. Don't tell me there's no parts. We're sending them to you. You've got it. Make the boards. So buying that pick and place machine was a defensive gesture so that we could actually get parts in, design, and get something built.
The building we're in here is partly offices, but downstairs are what we call labs, where we do a lot of testing. We use National Instruments stuff to test and gather data. We have built our own test apparatuses. It's confidential what project we're working on, but we built a big test picture for that project. So we have the ability to do that and lots of room to do it. I think there's 4 labs, and we do different things in each one.
Plus the prototype shop. We've got over 20,000 square foot of buildings here. Guest house, exercise room, the family house where she cooks wonderful meals and fattens everybody up, the brainstorming studio, our lab, our prototype shop, all on a campus. You've seen the pictures with the flowers and the trees. It is a place that we can pretty much build anything. Some of the big equipment, like for Rainone, we're in the midst of the oil patch. So big, heavy equipment. We run into Tyler or Longview and design something, do FEAs on it, do the testing, do the math modeling, and then set out the plans, get it built, and then bring it back here for all the electronic wiring and the control systems that we develop with the folks that we work with. There's hardly anything that we can't get done. We even have poured metal. We even have a small foundry that I built. She's laughing because we used to have it in Arlington, and I would fire it up, and it sounds like a jet engine.
This was at our house in a suburb, way back.
They'd freak out completely by having this jet engine roaring next to their backyard.
Those are old stories.
Old stuff, but we could pretty much build anything.
One of the questions that comes up with these incubators is intellectual property. How do you deal with it? Because it looks like you're going to be contributing a lot intellectually as well to these technologies. How do you manage that when a startup comes to you?
Boy, have you opened the can of worms. For the longest time, we simply said, it's yours.
The clients belongs to the client because they're paying us to develop.
And what we find is lots of applications where they won't do a damn thing with the item. So we now have an agreement called a joint R&D agreement with a great big oil company. And what they don't use, we have the right to go out and sell. sharing with them something that might come in from that. And we like that because nothing makes me more uncomfortable than good IP.
Just sitting somewhere. Yeah.
It's just stupid. And so in some cases, we're trying to, I won't say claw back, but more nudge back some rights on some stuff that they know they're not going to do. But I much prefer an agreement that will allow us to take some of the IP that has nothing to do with their path and go out and develop it and sell it on our own with them as partners in the reward, depending on how much they add to it, if they're interested.
It's a win-win situation. I like it. I know a lot of startups that shut down, IP is just sitting there. And when you put an effort to create that IP, I think we should do something about it. But I really like this model. And one other thing that comes up is with incubators and accelerators, they generally tend to take equity when they come and work with those facilities. What is your model like?
Remember, we're still in the process of fleshing all this out. We do have ownership in Renewell, not necessarily because we asked for it, but they wanted to give it to us. They have a small part of that. They gave me a small part just because I was a pain in the butt to them and helped them through it. PCD got a little bit too. Would like the base camp to have some equity to keep the base camp eventually fueled with money to help other base campers.
I guess the model's not completely fleshed out, but the options are a little bit of equity for services, for support, or a safe note, which would be we sell our engineering services to the startup, but they don't have to pay us right away. They can pay us in the future. So it's like a loan. It could be a combination of that or one or the other. And it depends on, I think if I were to guess a next base camper, it could be any of those, but it would depend on the project and what kind of resources they already come in with, et cetera. What do they need? Because we want to fulfill their needs, but it can be based on what's their comfortable.
Naresh, if you have some ideas, bring them on because you've talked to a lot of people and we would love the input on how we should do with that. Because if the base camp was flush with bucks, we would just bring people in and say, here's some money. Go spend it. Come here, live, we'll work. You can use us. You don't have to use us. But Basecamp doesn't. It's just starting. Maybe we're able to raise some money from VCs because now we're 501c3 on that. But it would be nice to be able to say, you fit the bill. It looks like you're good. You're dedicated, hardworking, got a good idea. You've done your homework. Come on down. We'll work with you. Here's a little money to push you along.
I love what you're doing. I haven't heard of any other incubator taking up your model. There's a good and the bad because these are all long-term bets and you won't see the fruits for a very long time and a lot of them fail to. So that's what happened in the Valley and in Boston areas where startups are full of a lot of money and incubators take equity and offer some services, but nothing like you guys are able to offer. I really hope you preserve this and actually grow on this. We'll have a separate conversation offline on this subject.
We'd love your advice and appreciate your input.
I love it. I'd love to do something with you guys. But here, I want to get your take on your observations about some of the most common mistakes that these founders do. If there's a common thread, because everybody comes and acts very surprised at the mistakes they're doing. And what I want this podcast to be is like that dictionary. They got to avoid these things, de-risk before you come to somebody like you or go give a lot of equity to an incubator and walk up with nothing.
I mean, where do products fail? They fail in the market because they're making dog food that the dogs don't want to eat, or else the dog food costs $300 a pound and nobody can afford to feed their dog that way. So they miss the market. They miss what it costs and what you get for it. I mean, $300 a pound for dog food that would extend a dog's life triple, that's cheap. I'd feed the dog that way because I love my dog. It has the feature. It's great. We're going to pay for it just to keep the dog alive forever. So miss the product. You miss the features at the price. You miss that. I think the startups don't always listen well because they're so enamored with the idea.
I think that's the biggest, honestly, because what I see most often happen is that you need to be really curious. You need to get lots of eyes on it. You need to have lots of advisors and not be afraid to have someone tell you you're going down the wrong path. The team is so important here. And getting someone who knows in depth about a particular industry, if you're not familiar with it, is super important.
Yeah, it doesn't require being a clever psychologist to hear it. I remember one in particular was listening to someone talk about something that had to do with animal welfare. And I said, well, did you check with A&M? There's a lot of folks over there that know about this. Well, they don't know about this, or they're not going to talk to me. I was like, what are you talking about? This is the excuse from hell. I'm going to not take your advice because I really don't want to know what experts are thinking. Sometimes experts are wrong, but it doesn't hurt to go out and ask a few of them about that. It's better to know now than go down that path, have everybody come back and say, yeah, we don't need that. It makes no difference. It's stupid.
Yeah, two points there, I think. One, listen carefully when you're getting advice. And second was talk. Like you mentioned earlier, Mike, pick up the damn phone and talk to people. Be prepared before you talk to somebody and ask curious questions, not be a smarty pan.
You're asking to get knowledge on how the decision is going to go, to make a decision. And if you're not open to the negative knowledge, the understanding, negative information, you are bound to fail because your mindset is already too immersed into it to hear the things that you don't want to hear.
I was having an interesting conversation with a friend last night about wealth and how knowledge is wealth. And that is the only form of wealth that people don't mind distributing and sharing with other people.
People are pretty generous if you ask them, and you ask in the right way. People are very generous.
I was at the receiving end for a long time. Like, people have been very generous. Like, you guys spending time with me to share what you have learned and with the rest of the world. And there are generous people like you all over the world. Speaking of generosity and kindness, looks like you've been together, married for a very long time. The reason I bring this up is I think it is, as an entrepreneur, it is super important to have the support of your spouse because these are long, lonely rides. I just wanted to hear from you guys, you're entrepreneurs in your own right. What worked, what didn't, and maybe advice for younger entrepreneurs.
You need to be each other's best supporters. He's always been my biggest cheerleader. And I told our son this weekend, and I've been his. I believe in him. And you have to have that belief in each other both ways. Even if it's just one of you in the business, you need that support and the belief. And when things go bad, you need to lean in more than pull apart. Because if you lean on each other, you'll find that support is so important to get through the tough stuff. So that's my advice. Pretty simple. Lean in.
Let me just amen that because we're not all up or down all at the same time. And sometimes you need someone to hug you, and sometimes you need somebody to kick your butt. I haven't had to kick her butt, but she's had to kick my butt. And it has been very important to do that. She's also a check on my profligate way. I am a bit of a tool nut. Oh, we have to have this tool, and we need this tool, and we need that tool. And it's like, if you're not going to put it to work, then you ain't going to buy it.
Well, I just ask lots of questions. And pretty much he talks himself out of it.
And she does. She's like, do we really need that right now? Well, it's always a compromise. Yes, no. Will that enhance us? Will that make us a better servant of our clients, the folks coming to us?
Great points. The reason I bring this up is because I deal with so many entrepreneurs, most of my friends, and they come to me for advice. And I said, like, make sure you get the support of your spouse or whoever, because if you don't have that support, don't do it. Because startups are very, very lonely and you're bound to fail in most of the endeavors, but this is a sure shot failure.
Because it's always going to cost a lot more to do what you think it's going to be. And there's going to be sacrifice. And if that support spouse is used to a certain lifestyle and it contracts, that's going to put real tax on that relationship. And I don't know that Donna knew I was as crazy as I was when she married me, but she comes from a very steady family whose father worked at LSU, was a VP or something at LSU all of his life. And she marries this crazy guy who can't work for anybody.
Maybe that's why I married you.
You both will get along well with my wife. I keep wondering, why did she marry me?
That's exactly. What were you thinking? Great judgment, except when it comes to men. You crazy.
Excellent. Hey, this has been fun. I learned a lot. Are there any things that we haven't discussed about PCDworks that the world should know?
Well, you brought up something about testing and the idea of being able to take something through all the testing systems and the nationally recognized testing labs. We didn't do the testing, but we studied and knew more about the requirements than anybody else. One of our mechanical engineers could go down and look at a circuit and say, that's not going to work. You're going to need resistors here, before we even took those for the testing lab, because those labs cost a fortune. And every time you have to iterate through it, it costs more money. It's all about knowledge, and it's about knowing ahead of time the kind of things that they're going to challenge you on. It's with everything. It's with working with outside consultants. All of that. You must be up to speed. This is no lazy person's profession. You must be diligent about what you learn and how you learn it and all of that. And that's really important. And by the way, when we do the immersion session, the client always pays for us to go find an expert in the area they're working on. So we bring outside experts in who know more about it than they do or we do, just to be able to add their 2 cents to the mix, because that richness of that intellectual soup is what makes creative solutions come forward.
Yeah, I cannot amplify how important that knowledge is. For example, that testing, I did that mistake of building the product without having any idea, because I was not a hardware guy. And then I had to halt because the testing guys came and like, oh, you don't have, the wheels should be of this side. They should be able to bear this weight. And starting with as simple as that the second time around, I had a consultant make sure walk through your designs and have all the requirements in place. But having somebody internal, that's saving a lot of money. I don't believe people understand how expensive and time consuming the whole process of failure is. And if you can avoid that failure, it's so much peaceful for your heart.
Save yourself a lot of heartache.
People say, you do prototypes. We do prototypes for one reason, to test them. We do math modeling, FEAs, all that stuff, electromagnetic FEAs. We do all of that modeling. That's a math prototype. And then we'll build a smaller prototype, maybe of a part or a piece. And then we'll add them together into a crummy engineering prototype by which we test the viability of the idea. Does it actually work? And then when you get into the real engineering, you're really testing not only for the viability, but for the reliability and for the buildability. Did you do this in a way that it can be built? And that's when you need to start involving the manufacturers and other folks, because as you know, you go down this path and they go, hell, I can't build that, or we can't find anybody to build that. You haven't done any. If it's been so specialized in the build that they can't get it manufactured, you haven't done them any good at all. You've just wasted that money. At least three different kinds of prototypes, and iterate through that.
All great points. Donna and Mike, and make sure I'll have your contact details in my show notes so people can reach out to you guys. But I love this conversation. I learned a lot, and I hope my audience is going to enjoy this as well. Good luck with everything. We will stay in touch. Thank you so much.
Wander down to East Texas. You just get lost out here, which you will. Just wave a flag. We'll come find you.
I will come visit you guys soon. Yes. Thank you so much.
Thank you.
Thank you for listening to this episode of the Lab to Startup podcast. You can find links to the resources and programs mentioned in these episodes, connect with Naresh, or subscribe to this show at labtostartup.com.